All right, here we go on our last study guide before the break, the 5.4.1. We skipped this one and are coming back to it for our last lesson of the week. So 2 words that actually are vocab words for the section. We already know these. Let's go ahead and write in some definitions of some things that we already recognize. These are the points where the graph of a function cross or touch the x-axis, right? So this is the point where the graph of a function crosses or touches the x-axis. A function may have zero, 1, 2, or more x-intercepts. What have most of our graphs had so far? Mostly our graphs have had 2 x-intercepts, right? Sometimes we had a graph that had 1 x-intercept, and sometime, we just started talking about imaginary numbers, we had a graph that had 0 x-intercepts. And next year in Math 3, you're going to have graphs that have 3 x-intercepts and more. All right, well, what about this word vertex that we've been studying? It's the point on a parabola where it changes directions. The vertex is the point where the parabola intersects the line of symmetry, or we also call this the axis of symmetry. So let's draw a quick sketch of this as well. Picture that you've got a graph with a vertex, and the graph is going down, 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 until the vertex, and then it's going up, 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 up. So this is the point where it changes direction, as well as it is the point right where the line of symmetry or axis of symmetry intersects. And those 2 different words mean the same thing, axis of symmetry or line of symmetry. It's that line drawn down the center. All right, let's go fill in a couple things here at the bottom. To sketch the graph of a quadratic function, we plot some points and connect them. Then the graph will be the shape of a parabola. And a parabola is a U-shaped graph. That U can be facing upwards or downwards, we're about to see. You could use the function's equation to identify key points on the graph. These points include the vertex. The vertex is the critical point of the parabola. And the x-intercepts. And the y-intercept. Oh, the y-intercept coming back in the picture. It's been like long lost and forgotten for so long. We've been focusing on x-intercepts for so much this chapter, but the y-intercept comes back into play now in this section. Use these steps to complete this example. So take a peek at what these are going to look like. All right. Substituting 0 in for x, solve for y, and write the results as the ordered pair 0, y. What are the steps for? How to find the y-intercept. Remember how Ms. Sanchez sings? For the y-intercept, the x is 0. For the y-intercept, the x is 0. So here we go. Plugging in 0 for x to find the y-intercept we can see that it's just 8. So 0, 8 is my y-intercept. For the y-intercept, the x is 0. Main idea, the y-coordinate of any x-intercept is 0. Use the given steps to complete this example. How to find the x-intercepts of a parabola. Well, we've been doing this a lot. When given standard form and substituting 0 in for y, try factoring first. Factor the trinomial. Well, we used a little method for this. What times what equals 8 and subtracts to give us the negative 6. So think of all the factors of 8, and hopefully you thought of 4 and 2. They should both have negatives to add up to negative 6. So my two factors are x minus 4 and x minus 2. Factor the trinomial, check. Now use the zero product property to solve for each x value, or 0. So x minus 4 equals 0, x minus 2 equals 0. We notice we're going to get the opposite signs from our factors when we solve. So 4 and 2 are my zeros, my roots, my solutions. But now they want us to write the x-intercepts. So I take this 4 and write 4, 0. I take this 2 and write 2, 0. We now have the whole shebang. I took my zeros and I wrote them as x-intercepts. Notice I used my method number 1, factoring, the easiest method to solve for these zeros and x-intercepts. All right, this next main idea, the x-coordinate of a vertex is the average of the x-coordinates of the x-intercepts. Use this step to complete this example. Okay, how to find a vertex of a parabola. So, and this is by using an average. So following these steps over here. Picture, if I'm trying to find a vertex, and I know these two x-intercepts, picture this graph. It's touching at 2, 0 and 4, 0, and here's the graph of my parabola. I want to know what this vertex is. Well, it's right smack dab in the middle of those two x-intercepts. So I can just take an average of those two to find the x-coordinate of this. So find the average of the x-coordinates to find the x-intercepts, and then substitute that x value back in to get the y, write the results as a vertex ordered pair. So here I go. I'm going to take an average by taking this x value of 2 plus this x value of 4 and dividing by 2. So 2 plus 4 is 6. 6 divided by 2 is 3. We just found half our answer. We know the vertex is 3, something. That's going to go, and doesn't that make sense if this is at 2 and this is at 4, that 3 would be right in the middle? So now how do I get that y value? Well, let's plug in to this equation. 3 squared minus 6 times 3 plus 8. Where does this 3 come from? We just got this x value of 3 by taking the average. 3 squared is 9 minus 18 plus 8. And we're going to get negative 1. All right, so the y is negative 1. I have the other half of my answer. This is my full vertex. So just to say again, what did I just do? I found the middle of the 2 points by taking an average of the x value of the x-intercepts. Then I took that 3, plugged it in for x to get the y. This is now my full vertex. The coordinates of this vertex are 3, negative 1. All right, let's see what they're having us do next. Sketch the graph. Woohoo! So sketching the graph of this, start by identifying and plotting all those points you just found in part 2, part 3, and part 4. So the y-intercept that we just got was 0, 8. Go look back at that and see where we got that. The x-intercepts we just got are 4, 0 and 2, 0. Go look back at that and see where I got those from. The vertex I just got is 3, negative 1. These are the parts from everything we just did. Now we go graph it. Start by graphing any of those parts. It doesn't really matter, but let's go graph the y-intercept first. 5, 6, 7, 8. 0, 8 is my y-intercept. X-intercepts of 4, 0 and 2, 0, oops, got 2 and 4, so 1, 2, 3, 4, 5, okay. And then my vertex of 3, negative 1. And then you just connect it, and this is your graph. Now, some people do realize that there's symmetry in a parabola and that we could actually put this other point over here if it makes you feel better. So symmetrically, if I have this 0, 8, this is how many over from the vertex, right? 1, 2, 3. So we could just go 1, 2, 3 in the other direction symmetrically. If you like putting that other point of symmetry in, feel free. And then we just connect this. And there's my parabola. So, main idea, you can use the first part of the quadratic formula to find the vertex of a parabola. We then can get the x-intercepts by factoring and plotting those. And after we have the vertex, the two x-intercepts, we can also get a y-intercept. Then we can use that point to do symmetrically exactly on the other side, connect it, I have my graph. All right, let's look at the last part. Identify A and B and substitute in. So real quick, I told you guys in our notes that there were two parts of the quadratic formula, right? There was the discriminant, which told us how many roots. And then there was the formula for the vertex of a parabola. Well, that's what we're using right now. Formula for the vertex, okay? So this is part of the quadratic. We need A, B, and C. And then we plug in just into this little tiny part. Negative B over 2 times A. So I just got that X was equal to negative 2. I have half an answer. That is my X value of the vertex. Now substitute this result back into the equation to solve for Y. Remember to do exponent before multiply. (12 minus 24 is negative 12. Negative 12 plus 1 is negative 11. How'd you do? The vertex of my parabola is negative 2, negative 11. All right, I'm going down to this next part. The graph of a parabola from vertex form, we're going to start by identifying and plotting the, you got it, vertex. The vertex of any parabola given to us, notice how this is in vertex form. So HK is my vertex. And the vertex of this would be negative 2, negative 7. Remember that it's the opposite sign of the X. The H. Okay, let's go see. So how to use the x-intercepts to write the equation for a parabola. Start with the x-coordinates of the x-intercepts, write them as factors. So if I'm given the x-intercepts, I'm now going to work backwards to write the factors. Remember that if it's a positive 2 intercept or zeros, it's a negative 2 factor. And then FOIL them to multiply. And that's my product. That's my equation. Y equals x squared minus 6x plus 8. So if we are given the x-intercepts, we can get the factors. We can multiply those factors and write the actual equation. So we can work backwards to find the equation from the factors too. How exciting, right?